So this is a discussion on the part B, set M. Part B, we have 75 marks, and this is a question 1. Given the function f(x) as this quadratic, find the possible value of p when this limit is given. So we are using this information, the limit of f(x) when x approaches to p is equals to 5. Using this information, I will try to form an equation involve the p and solve for the p. So first of all, just put in the function of f(x) as your quadratic function, which is given. That is your negative x minus 2 squared plus 9. And this is given as a 5. Just put in the 5. So as I said, to evaluate limit, you will start with the substitution method first. Just put in the p into our x. We have your negative p minus 2 squared plus 9 equals to 5. So can you see that I already successfully formed an equation involve the p. Now we're going to solve for this equation. We have your negative p minus 2 squared equals to negative 4. Multiply negative 1 at both sides. You have 4. And now you want to eliminate the square. The square, you actually take this square root both sides. Okay, you got a positive negative 2. Sorry, you have a positive negative 2 because the square root of 4 equals to 2. Then you actually got two sets of answer. The first set should be p minus 2 equals to 2, and the other set is p minus 2 is equals to negative 2. Now, solve this. You have p equals to 4, and the other set has to be 0. So you actually got the two sets of answers. And for the question 2, you're given a piecewise function f(x). Then we need to calculate the limit. This is a left-hand limit, and this is a right-hand limit. Then from this left-hand limit and right-hand limit, you're going to conclude that the value of this limit of f(x) when x approaches to 0. Alright, because the 0 here is the boundary value in our interval, we need to be careful because left hand of the 0 and right hand of the 0, it has the different subfunction. So to get the left-hand limit first, that is x approaches to 0, negative, we need to choose the correct or corresponding function to put in here to substitute the f(x). So when x approaches to 0 negative is 4 in this interval. So the corresponding function should be square root of 1 minus x. So just put in the square root of 1 minus x. And followed by the substitution method, substitute the 0 inside, you get a 1. Square root of 1 equals to 1. And now then we proceed to the right-hand limit. When x approaches to 0 from the right, 0 positive, you can imagine that is something a little bit greater than 0. So a value greater than 0 will be 4 in this interval, a little bit greater than 0. Then we're taking this function to put in as our f(x). Just put in 3x cubed minus 2x squared plus 5x over 5x. Then to evaluate this limit, I think I will try to simplify because when you put in the 0 inside here, you got 0 over 0. Alright, we always start with the substitution, yes. But after substitution, we got 0 over 0. Then we should proceed to the next step. That is, either we factorize or multiply by conjugate. So for this function, we can see that on top we have polynomial. It can be factorized into x. Alright, you can take out the x, and inside the bracket, you still have 3x squared minus 2x plus 5. And down here, we got 5x. So for this, after we have factorized, we can see that actually the x can be cancelled off. Once the x cancels off, you can direct substitute the 0 inside. Substitute the 0 inside the function. You got your 0 minus 0. That is your 0 minus 0 plus 5 over 5. Then finally, we have 5 divided by 5. That will be equivalent to 1. Then followed by the limit of fx when x approaches to 0, we need to consider these two values. That is the right-hand limit and the left-hand limit. So if the right-hand limit and left-hand limit, they're having the same value and both are defined, then we say that the limit when x approaches to 0 will be that value, the same value. Alright? So we say that since limit when x approaches to 0 positive is equals to the limit when x approaches to 0 negative. This is my reason. Then my conclusion is the limit x approaches to 0 of the fx, okay, limit of fx when x approaches to 0, it has to be equals to 1. And actually we can say that it is exists because you got the value, a defined value for the both right hand and left hand limit. They are the same, then we can say that the limit when x approaches to 0 equals to 1. Then now we proceed to the B, question B. Find the Q. Find Q if the limit when x approaches to 2 exists. Again, the 2 is the boundary value. So if you want to find the limit, okay, you have to be careful. You have to consider the left-hand limit and the right-hand limit, because at the left hand of 2 and left and right of the 2 will taking the different subfunction. Okay, so since the question say that this is exists, meaning that its left-hand limit has to be equal to the right-hand limit. So we're using this information help us to get the answer of the Q. So we say that this right-hand limit is equal to the left-hand limit when x approaches to 2. Okay, so you need to find the corresponding value, the function put in as your fx. When x approaches to 2 positive, meaning that a little bit greater than 2, it falls in this interval. So the function is 11 minus qx. Just put in 11 minus qx. Then when x approaches to 2 negative is 4 and somewhere here in this interval. So we need to take the second function. That is my 3x cubed minus 2x squared plus 5x over 5x. And don't forget that just now we have simplified this function. This function, we have simplified it. So we can just copy down if you want. Okay. Then you can simplify this first, or you want to substitute. It's up to you. Substitute the 2 negative directly. It's up to you. But for me, I simplify first. I got my 3x squared minus 2x plus 5 over 5. After I have cancelled off the 5 at the part A, see or not? Part A, we have to cancel off the x. Then for the right hand limit, just copy it back, or okay, copy it back first. Then now I'm going to use substitution method to find this limit. Put in the 2 inside, I have my 11 minus 2q for this. And for this one, for the right hand side, I put in the 2, I have my 3 multiplied by 4 minus 4 plus 5 over 5. And simplify this, you got 12. 12 minus 4, that will be 8. 8 plus 5, that will be 13 over 5. Then solve for this. You have your 2q equals to 11 minus 13 over 5. And final answer for the q is 21 over 5. So come to the question 3a. We need to differentiate this function. To differentiate this function, I will apply these product rules, because the power of 4 here is too high to expand. So we will apply the product rule. To apply the product rule, we can simply just let one of it to become the u and the other become the v. So here I'm using this u as my 2x and the v as 1 over x minus 3x squared. Then you can get your u prime as 2. And the v prime, you just take it as differentiate it as a 2-layer function. You differentiate layer by layer. To differentiate the power of 4, you bring 4 to the front, and the power minus 1, you got 3. So this is the second layer, you just put into the bracket first. After that, multiply by, differentiate the inner layer. You got your negative 1 over x squared minus 6x. Okay, so just write it nicely. This will be the one you have for your v prime. After you have this, just put into the formula uv prime plus vu prime. U is your 2x, and the v prime is 4 negative 1 over x squared minus 6x. Multiply by 1 over x minus 3x squared power of 3. This is your v prime. This is your, the whole term is your u multiplied by v prime plus vu prime. Take in the u, put in the u, v. You have this, and u prime is just 2. Alright, and now we can just factor out what is, the common factor. You can actually focus on the first term. This is your first term, and this is your second term. And check if you have any common factor between these two terms. I see that these two terms both can be divided by 2, so I take out the 2. And both can be divided by 1 over x minus 3x squared power of 3. So I take out this power of 3. Alright, we see this factor, and which is lesser the power, we take out that, okay, that factor. And after we have checked both terms, okay, there is no more common factor, then we can just end up by open up the bracket, put in what the first term, what you left for the first term once you factor this out. You factor out the 2, you factor out the 1 over x minus 3x squared power of 3. So what you left here is just 4x, and multiply by negative 1 over x squared minus 6x. Plus, this is our second term. Once the second term, take out the 2 and 1 over x minus 3x squared power of 3. What you have is a 1 over x minus 3x squared power of 1 only. So what you need to do now is just simplify what is inside this bracket. So this is already done. Simplify. You don't go and disturb anymore. You just need to simplify this. Just expand first. Expand this. You have your negative 4 over x plus 24x squared. Alright. Plus 1 over x minus 3x squared. So here you have 1 over x minus 3x squared power of 3. And these two terms is the like term. They are like terms, so you can simplify them. You're taking the negative 3, negative 4 over x plus 1 over x, you get negative 3 over x. And 24x squared minus 3x squared, you got 21x squared. And we can see that this, both of these terms still can take out the negative 3. Okay, once you take out the negative 3, multiply by the 2, you get negative 6 here. And copy down this. Once you take out the negative 3, what you have is your 1 over x. And take out negative 3, this one change into the negative. You got a 7x squared. Alright, so this is my answer. Alright, here's some correction. I made a mistake on this sign. So 64 multiplied by negative 6 here should be negative. So you got a negative 27. Yeah, negative 27. This should be negative. And finally, you have you take out the negative 3, right? You got a negative 9. Okay, this is a negative 9x squared. Alright. And this should be positive. Alright. Once you take out the negative 3, because this is negative 27, take out negative 3, factor out the negative 3, it's just like that. It's 2, 1 over x minus 3x squared, power of 3. And factor out the negative 3, you got your 1 over x. And the negative, take out the negative, you got positive for 27. Okay, positive 9. Okay, positive 9. Positive 9x squared. Then negative 3, you join with the 2, you get negative 6 here. Finally, you get this answer. So for the question 3b, this is the question 3b, section B. Okay, so we need to differentiate this function, and we can see that this function cannot be simplified. So if we want to differentiate, we need to set the numerator as a u and denominator as a b. So when your u equals to square root of x, meaning that is equals to x power of 1 over 2, then u prime should be 1 over 2 x power of negative 1 over 2. And if you simplify, you get a 1 over 2 square root of x. And the v, set it as a 2x plus 1 power of 6. To get the v prime, just see this as a two-layer function. Differentiate the first layer, we have a 6 in the bracket, power of 5. And what is inside the bracket, we just put in. Then multiply by, differentiate the second layer, which is the 2x plus 1, you get 2. Simplify, you have a 12, 2x plus 1 power of 5. And now I'm going to put into my formula to get your dy dx by using the quotient rule. Copy down the v first, and then u prime minus uv prime over the v squared. Right. Then now I'm going to put in my v as a 2x plus 6 plus 1 power of 6. And the u prime is your over 2 square root of x, because multiplied by 1 over 2 square root of x can be written in this form. And uv prime, u is a square root of x, and v prime is 12, 2x plus 1 power of 5. And all this is going to be divided by the v square, which is your 2x plus 1 power of 6, and then square it, you get a power of 12. Right. Then how am I going to simplify this? To simplify this, I need to equate the denominator on top, meaning that for the first term, I can see that I have a denominator 2 square root of x. Here also, we need to multiply by 2 square root of x. Down here, multiply by 2 square root of x. Then finally, I have the same denominator, which is my 2 square root of x. Alright, and for the first term, I got my 2x plus 1 power of 6 minus. Okay, when you have the second term multiplied by 2 square root of x, you got a 24. Alright, 12 multiplied by 2, 24. 24 third of x multiplied by third of x, you get x. And the rest, you have your 2x plus 1 power of 5. And don't forget, down here, you still have 2x plus 1 power of 12. It can be joined for the denominator as 2 square root of x multiplied by 2x plus 1 multiplied by 12. You can write in this form. After you have done this, then you need to factor out the 2. You can see that you have a common factor, 2x plus 1 power of 5. For these two terms, you got a common factor, 2x plus 1 power of 5. Once I take out the 2x plus 1 power of 5, what I left here is 2x plus 1 power of 1 only. And here I have a 24x. Okay. Then down here you have a 2 square root of x, 2x plus 1 power of 12. And we can see that these two actually can be cancelled, can be simplified. Alright, this becomes 7. Alright, because base, they're having the same base and the power can be minus. And inside here, what we left is 2x minus, you got a 1 minus 22x, alright, over 2 square root of x, and multiply by 2x plus 1 power of 7. This is your final answer. Proceed to question 4. For the function a, we need to differentiate. This is a very simple question. We just need to expand it. Alright, expand it, you will have e power of negative 2x minus e power of negative 4x. Alright, because the base are the same, so the power can be plus. You add up. Then dy dx is the differentiated term by term. Okay, how to differentiate the e power of fx? You differentiate the power first, you get negative 2. Then copy itself back, you get the e power of negative 2x. Minus, okay, the negative just copy down. And differentiate the negative 4x, you had negative 4. and copy down itself, you got the e power of negative 4x. Then after that, you can simplify it. You have a 4, alright, 4 e power of negative 4x minus 2 e power of negative 2x. Then if you want to factor out the 2, you can do so. You will get the 2 e power of negative 4x minus e power of negative 2x after you have factored out the 2. For the question B, you just need to apply the laws of log, where you gotta, if you have a log A over B, you can simplify into the form of log A minus log B. Alright, so now I'm going to use this law, and I will make my y look like this. Minus log 3x plus 1. Alright. Then I will start to differentiate. To differentiate this function, again, you must remember the formula to differentiate the log. To differentiate the log function, for example, I need to differentiate log gx, for example. Alright. The formula is you differentiate the gx first, you get your g prime x, and then divided by the gx itself. So this is the formula to differentiate the log gx. So once now you have the log 2 minus x, as if that this is your gx. Differentiate the gx. I'll write it down here. dy dx equals to differentiate the gx. You got a negative 1. Divided by the gx, you have a negative, 2 minus x. Minus. Alright, so now your gx becomes 3x plus 1. Differentiate the 3x plus 1, you got 3. Divided by the gx itself, you have a 3x plus 1. Alright, then after that, you need to simplify. How do we simplify? I will try to equate the denominator. To equate denominator, this one I need to multiply by 3x plus 1. And up here also need to be multiplied by the same thing. Okay, for the second term, I need to multiply by 2 minus x. Up here, I need to multiply by 2 minus x also. Okay, then now we're trying to equate denominator. So now the denominator becomes 2 minus x multiplied by 3x plus 1. Okay, here I need to expand it and simplify. I got my negative 3x minus 1 minus 6. Negative multiplied by negative, you get positive 3x. So you can see that you have, this is your 6, right? So here we have a negative 7 over 2 minus x, 3x plus 1. Alright. Let's proceed to this question C. We need to differentiate this function. So this function, simple. We just treat this as a 3-layer function. Okay, we got negative 6. And I'm going to write this into this form so that you can see clearly. The power of 2 here means that the cos, everything, the whole thing, power of 2. So I'll treat this as a 3-layer function. The first layer is power of 2. Second layer is a cosine. And the third layer is x squared minus 1. To get the dy dx, we're going to differentiate layer by layer. To differentiate the first layer, that is my 2. I will bring the 2 to the front. Join with the negative 6, I got negative 12. And I prepare one bracket to put in my second layer and third layer later on. Then the power of 2 minus 1, I got 1. Then the second layer, I just copy down. Third layer, I just copy down. Multiply by, differentiate the second layer, that is your cos. Differentiate cosine, you get negative sine. You get negative sine. And then the third layer, you still need to copy down without doing anything. Alright? Then multiply by, now it's a turn to differentiate the third layer, which is my last layer. I got my 2x. Differentiate x squared minus 1, you got 2x. After that, you have done everything. You just simplify, you got the answer. Negative 12 multiplied by negative 1 multiplied by 2, you got 24. 24 cos x squared minus 1 and multiply by sine x squared minus 1. Just like that. So to find the dy dx for this function e power of 5x over 1 plus x, again, you set this as a u, this as a v, then going to apply the quotient rule. Just find out your u as your e power of 5x, then get your u prime, that will be 5 e power of 5x. Differentiate the power, you get 5. Copy back itself, you have an e power of 5x. This is how we differentiate the exponential function. And the v as your 1 plus x, the v prime is 1. Now I'm going to find the dy dx by putting into the quotient rule formula. I get this over v squared. Okay, so plug in all the corresponding v, u, and u prime, v prime. You have your 1 plus x as a v, and the u prime as a 5 e power of 5x, minus u is a e power of 5x, and the v prime is 1, divided by v squared, which is your 1 plus x power of 2. And you can see that you can factor out the e power of 5x for this both term. After you factor out the e power of 5x, you still have 5 plus 5x, alright, minus 1. Okay, divided by 1 plus x power of 2. Then inside this bracket, you still can simplify. That is your 5x plus 4 divided by 1 plus x power of 2. For this question B, I will use the product rule to differentiate this function. I'll let u equals to 8x squared, and then u prime is 16x. Then set your v as a cos 3x. Get your v prime is your negative 3 sine 3x. Then now we'll get the dy dx first by using the product rule. After we got the dy dx, we will substitute the x as a pi over 4 and get the final answer. So let's find out what is the uv prime. Uv prime is 8x squared multiplied by the cos 3x, that is a uv prime, plus vu prime. V is your cos 3x, alright, v prime. So v prime has to be negative 3 sine 3x, and plus vu prime, v is your cos 3x, and u prime is your 16x. Then we just simplify. X squared, negative 24x squared sine 3x plus 16x cos 3x. So once you have the dy dx, we can start to put in the x as a pi over 4. Just put in the 24. This one will be pi over 4 square. And pi over 4 you put in, you will get 3 pi over 4 plus 16 multiplied by pi over 4. And the 3x again, you got a cos 3 pi over 4. So with assist of calculator, you can calculate the answer now. If you can give your answer in decimal number. So if you're going to use this pi to put in your calculator, you will remember to change your calculator mode into mode radian. Then finally you get a negative 19.35. Or you can give your answer as a negative 19.4, very significant figure. So question 6, to integrate this function, we're going to expand first because the power is just power 2. So the power is not that high, we can still manage to expand it. Alright, after expand, we can easily integrate. So after we expand, I have x minus 2 third x plus 1. And this is going to be divided by the third x. And then expand further. You can separate into the 3 separate terms. X divided by square root of x, you have x power of 1 over 2. And negative 2 third x divided by third x, you get negative 2. plus 1 over x is x power of negative 1 over 2. Then now we can integrate it. X power of 1 over 2, you integrate, the power is going to be at 1 and divided by 3 over 2 minus 2x plus, this is going to be plus 1, you get 1 over 2 and divided by 1 over 2. And because this is an indefinite integral, then we plus constant c. So how we're going to simplify this, you bring up the 2 on top, okay, then you have your square root of x power of 3 over 3 minus 2x plus 2/3 of x plus c. Alright, for the question 6a, we got alternative method, which just now I have expand and integrate. Here is an alternative method, which I'm using the substitution method. Let the u equals to square root of x minus 1. You find your du ds, you got 1 over 2 square root of x. And then after that, we can see that the 1 over square root of x dx, it can be substituted as a 2 du. You see you're not here. 1 over square root of x, I bring up the dx to the right. I got a 1 over square root of x dx, and then bring the 2 to the left. I have 2 du. Meaning that 1 over square root of x dx, it can be substituted as 2 du. Then what I have is, I can just put this as a u square, and 1 over square root of x dx will be written as a 2 du. Bring out the 2, then you just integrate the u square with respect to u. You have a u cubed over 3 plus c. Then the u, you need to put back as a square root of x, let me see, square root of x minus 1. Okay, you need to substitute the square root of x minus 1 as your u. And this is a 2 square root of x minus 1 power of 3 over 3 plus constant c. So you either can have this answer or this answer. To integrate this function, we are not going to expand because this power is too high to expand. So I will stick to the substitution method. You let your u equals to 2x plus 3 and find the du dx. Once you set your u, you need to find du dx. Alright. Then later on, the dx can be replaced as a du over 2 over 2. So the dx here, it can be replaced as a du over 2. And the 2x plus 3 later on going to be u. And how about the x? The x here, I need to find from the u equals to 2x plus 3. I find the x as my subject. I got my x equals to u minus 3 over 2. Meaning that later on, this x is going to be u minus 3 over 2. So now we can see that everything is succeeded in terms of u. We can just rewrite our function to be in terms of u. The first one is a u minus 3 over 2. Second one is a u power of 4. And the ds is going to be du over 2. Over 2, again, I will take it out as a coefficient. So here you can see that I got the other 1 over 2 inside my integral. I can just bring it out. Then finally, I got my u minus 3 multiplied by u power of 4 du. And you can see that now our integral inside the function can be expanded. It can be expanded. You can expand as a u power of 5 minus 3 u power of 4. So once you expand, you can see that the function is so easy to integrate. Integrate u power of 5, you get u power of 6 over 6 minus 3 u power of 5 over 5. Plus constant c again because this is indefinite integral. And finally, we need to substitute back the u as 2x plus 3. Alright, so put in the u as a 2x plus 3. This is power of 6 over 6. Alright, this is minus 1. Alright, 3, 2x plus 3 power of 6 over 5. Plus, that's it. Sorry, this will be 5. This will be 5. Okay, and you can see that you can actually factor out the common factor of these two terms. you can take out the 2x plus 3 power of 5. Then what is left inside the bracket? You still have 2x plus 3 over 6 minus 3 over 5. And keep on simplify the bracket. What is inside the bracket here still can be simplified. Got a 1 over 4, 2x plus 3 power of 5. Inside here I got a 2 over 6. Okay, that is 1 over 3x. 2 over 6x is 1 over 3x. And then 3 over, this is a 3 over 6. 3 over 6 minus 3 over 5. Alright, that's it. Alright, this is the question 7. Question 7, we need to get the value of the L and M. So here you can see I write 1, 4. So how do we get the 1 and the 4 here? Because the L and M is an x-intercept. So you need to find 1, 4 by letting the y equals to 0. So if you let y equals to 0, then you need to factorize. Factorize, you get 4, 1, negative, negative. From here, you solve it. You get it x equals to 4, x equals to 1. And now the question asking for the coordinates, right? So coordinates meaning that you need the value of y. When you write the coordinates, you need to write down the coordinates as a x coordinate and y coordinate. So L is having the x coordinate 1, and of course the y coordinate is 0. And the M also the same. M having the x coordinate 4 and the y coordinate is 0. So this is the coordinate of the L and the M. For the question B, we need to integrate this function. So just we know that this is finding the area, some sort like that, but we don't care because the question just find this. To find this, we just integrate x squared minus 5x plus 4 dx. So just integrate as usual. Got the x cubed over 3 minus 5x squared over 2 plus 4x. Alright, plus c. Because this is an indefinite integral, just plus c. And it cannot be simplified anymore. You just leave your answer like that. Then next, we need to find the finite region R is bounded by Ln, Lm. Where is my Ln? Ln and Lm. Alright, the region R is shaded for you. And the curve C as shown in the figure 2. Use the answer from the part B to find the exact value of the area R. So I just need to get this region, I will need to look at this diagram. To find the R, I need to find this triangle, the region of the area of this triangle first, meaning that I need to find the equation of this straight line maybe. And then after that, I integrate this straight line. I got my triangle area. Then after that, I find this area. I take the triangle, the area of the triangle minus the area that I shade here. I got the area of the region R. So firstly, get your triangle first, the area of the triangle. To get the area of the triangle, I need to form the equation. So equation for the straight line is y minus y1 equals to mx minus x1. Here my m is I just can take y2 minus y1, which is this is my 1, 0, this point. y2 minus y1, that will be 4 divided by 5 minus 1. 4 minus 0, that will be 4. 5 minus 1 will be 1. Will be 4. So I will get this 1. Continue by finding the equation. y1, I will just take this as my y1. y minus 0, m, I put in 1. And x minus x1. x1 will be the 1. So my equation will be x minus 1. So to get the area of the triangle, I need to integrate from 1 to 4. This is 5. This value is 5. Alright, look at this coordinate. This is 5. Integrate from 1 to 5. And the function is x minus 1. Integrate with respect to x. You got your x squared over 2 minus 1, minus x, and then put in your limit. Okay? Here I got my area of the triangle, Alright, this right angle triangle is 8 units square. Then now I need to find this area by using the result that I got it just now here. I can get my area. The area is using this result. So the area I can just write like this. Area of this shape. Okay. Maybe you can label it as the R1. Okay. So you can say that the area of the R1 is equals to this one already integrated. So you can just put in the function. You do not need to do the integral one more time. Because the question asks you to use the answer in the part B. Okay, if you integrate again, meaning that you will lose marks. Okay, plus 4x. So to get the area of the shaded region R1, you are going to integrate from 4 to 5. Integrate from 4 to 5. And then after that, you put in the value, substitute the upper limit here. So after I have substitute the upper limit and lower limit, I got my area of the R1 is 11 over 6 units square. So taking to get the area of the R, so the area of the R will be taking the area of the triangle minus the area of the R1. Just now we got it, area of the triangles is 8, right? Minus 11 over 6. Finally, you get a 37 over 6. Okay, 37 over 6 units square. Alright, thank you for watching.